kind of shown you guys a little bit of this throughout the past week or so. What happens with these whole rational zeros is that you get, if I want to figure out what the rational zeros of this polynomial, we have a third degree polynomial, x cubed plus 2x squared minus 11x minus 12. Now, we've said this a lot, and I know it's been a while just to kind of get our brains back. What are the dance moves doing? They're down up, okay? You're dancing down up. It's a third degree polynomial, which means how many parts should be in the polynomial itself? 4 parts, cubed, squared, linear, and constant. How many possible zeros are there if it's a third degree polynomial? 3 of them. There's 3 possible zeros. And then how many changes of direction can this graph have? 2. Okay. That's where you're going with that. So remember, you have, when you're talking about polynomials, nth degree polynomials have nth number of zeros, n minus 1 possible changes of direction. And then your dance moves are dependent upon even or odd with the positive or negative, the coefficient of the first term. Okay? Now, when we did this before, when we tried to factor this out and find our zeros, when we have 4 terms, remember the strategy that we showed you guys was that you'd always try to factor via grouping. Okay? Now, if you did that and you looked at this saying, hey, it's x cubed plus 2x squared minus 11x, and you would try to group that out, you take a GCF, you get x squared, x plus 2, but then you get stuck there, and there's no GCF that allows you to continue to group. So for a while, we would say, all right, I can't factor that. And if they don't give you a possible zero to start with, remember how we were doing that last week? If you knew that f of, I don't know, say -1 was a 0, you could have factored out the -1. Remember that vaguely? Well, this is what happens when you don't have any of the information at all. So what you do is that you look at your tails. And by tails, I mean first term coefficient and last term. Okay? So what is my last term? 12. It's -12. So what I do is I look at all the factors of -12, and I divide that by all the factors. What's the coefficient up front? 1. Okay. So basically what this means is that I'm looking at the factors of my n divided by my factors of the front. And what I mean by factors is what times what's 12. So you list it out. Excuse me. We know it would be plus or minus 1, 2, bless you, 3, 4, 6, 12. All divided by plus or minus 1. Bless you. Everybody okay with that? So what we're doing here is, if I'm looking at this, what's called the rational zero theorem, if you will, in order to figure out where to start factoring something that you can't just automatically GCF or group or factor like a trinomial, what you're going to do is you use this idea of looking for their possible zeros. Now in this case we have plus minus 1, 2, 3, 4, 6, and 12, which means there are a total of a possible 12 zeros. Okay. Plus or minus 1, plus or minus 2, and so on and so on and so on. What you do with this then is you just pick one and go. So this rational zero thing is basically you take all, and don't write all this out, take the factors of the constant at the end divided by the factors of the leading coefficient. And that allows you to figure out what are all of the possible zeros. So think of it as factors of possible zeros. Is it ES with zero special? No, I didn't think so. I didn't think so. Look, I think it would look weird. It would be factors of constant, the divided by factors. I think that's the easiest thing to do. Factors of the constant divided by factors of the leading coefficient. And that's what you would do to list out all the possible zeros. Now, there are going to be times where you could get up to 15, 20 different possible zeros. You could get like a ton of these things. Now, it may look like it becomes a very daunting task as far as what you're going to do is to check for zeros. But as you guys know that when you're synthetically dividing, isn't that a relatively quick process? Yeah. So as you go through these things, even though you're getting all these possible zeros, you know that if you find a zero, you'll be able to generate its term rather quickly. So let's try a couple examples. If I want to find the possible zeros of 4 and 5, let's list them out. I thought it was the you got that throat thing too. The kids were fighting and I'm starting to get it too. It's a great week to get sick. Yeah.
I was sick.
Children's in their boogers, I tell you. So I look at the first one. You're looking at the factors of 56 divided by the factors of 1. You just have to list them out. There's a lot, yeah. Yeah, so if I'm looking at 56 and 1, so it would be 1, 2. Do you guys remember the trick for deciding whether or not something's divisible by 3? Go ahead. Yes. Yep, if you add them together, and if it's divisible by 3, then it is. What's 5 plus 6? Is that divisible by 3? No, so it's not divisible by 3. 4, I think 4 is, because 40. Yeah, and this one, if you just think of it in 4, 4 goes into 5 how many times? How many are left over? So 4 times 14. Obviously, 5 won't work. I believe 6 works if 2 and 3 work. Did 3 work? Therefore, 6 won't work. Does 7 work? Which means the next one is, and you're on your way down. Was it 28 and 56? And these are all plus minus. Okay. So in this case, we have what? 1, 2, 3, 4, 5, 6, 7, 8. There are 16 possible zeros. Okay. There are 16 possible zeros. What's that? You just have to know. Yeah. All right. What do you do with 72? If you feel like you need to go find that brownie, knock yourself out. 72s are kind of annoying because there's a lot of numbers that go into 72. Yeah, all I'm doing is list possible zeros. So we're listing possible zeros for it. We'll get to what you do with them. We're taking baby steps. Like I said, I wanted to slow it down just a smidge because I know we had a little bit of time this week. Okay. Yeah. Hey, if by chance I allow you to use a graphing calculator to figure out your possible zeros, table. Now, what would you do to figure out your table? What would you do that by? appreciate the I got set up.
I know.
The shortcut way to do this, if you are allowed to use a graphing calculator, which means you probably won't be. Oh, you hit y equals. Do 72 divided by x. If you do 72 divided by x, it'll list out all the factors. Then you'll be able to see whether or not it's divisible. See what I'm saying here? That gives you your list of clean factors. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72.
Now, partridge in a pear tree.
I don't know, it's on the thing. One, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. All divided by 1. Now, one of the things here, just so you guys know, we have plus or minus here. When you do this, you do not need to write down plus or minus at the top and at the bottom. It's okay to just leave it at the top. Because obviously, when you start dividing things out, even if we do have more than one value, like a singular constant in the denominator, as you go through it, it'll still be plus or minus. Okay. So this one you wind up with, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 possible zeros. That's fun. Now, it gets a little weirder when you have stuff that is the leading term coefficient. Because then you have to list out. Now, again, it's not that it's horribly difficult. Oh, I'm so sorry. Quit your complaining. You'll get over it. So, enough. It's old. I get it. You guys are high school kids. God forbid you do some work. So, I get it. Now, as you get into these, these usually wind up being the types of questions that I've seen. I haven't seen like enough SATs to tell whether or not they would ask this question. But I know on the ACT they said how many possible zeros of the polynomial are there. So you'd have to know about the tails things and put them together to count them out. So I've seen stuff like that, but I don't know if it's dependent on the ACT or the SAT to tell you the truth. So if I'm looking at 2x cubed, 7x squared minus 7x plus 30. I'm going to take all of my factors of 30 divided by all my factors of 2. So you have plus or minus 1, 2, 3, 5, 6, 10, 15, 30, all over 1 and 2. You okay with that? Which means, as you go through this, now you can write out separate fractions. Some of them are duplicates, and some of them aren't. For example, if I go through this and I divide all of my numerator by 1, I'm left with plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Okay with that? And then if I go back and divide everything by 2, I get plus or minus 1/2, 2 over 2, 3 over 2, 5 over 2, 6 over 2, 10 over 2, 15 over 2, bless you, and 30 over 2, bless you. And that's what I was getting at. As you get into this part, you'll notice 2 over 2 is also 1, so I don't have to list it because it's already been counted. This one goes away. 3 over 2 is new. 5 over 2 is new. 6 over 2 is 3, so it goes away. 10 over 2 is 5, so it goes away. And then 30 over 2 is 15, so it goes away. So yes, you go ahead and simplify some of those and check to see if they've already been counted. Yes, ma'am? If you just knew that it was already there, and you just went from 1/2, 3/2, 5/2, that's fine. I look at it this way because that way I don't make a dumb mistake. Yeah, that's perfectly fine. I have no problem with that. Because a lot of times as you're writing it down, you're like, oh, I turned it off. So when you start getting things with leading term coefficient as well as tail, it's so easy to all of a sudden get, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's what, another 24 possible? So it's really fast to start getting large possible amounts of zeros. As you get into some of these things, you'll find out real quick that most of the time, when we start fishing for zeros, you usually start to find them probably within the first 2 or 3 that you do, and then they become real quick. But it's also the idea of, can you list them if needed? And the last one there is 5x to the 4th, 12x cubed, 16x minus 16x squared, and a 10. Does this listing possible zeros change, do you think, if you're missing a term in the polynomial? Nope, not at all. Because if you look at it, what's your tail? Your tail's still a 10. Your front term's still a 5. So you have all your factors of 10 divided by your factors of 5. This one's a lot easier. You get 1, 2, 5, 10 over 1, 5. So it's really just going to be, what is that? 1, 2, 5, 10. And then plus or minus 1/5, 2/5, because everything else is replaced. And that's kind of what you were saying, Andy. Can you just rewrite it like that? That's fine. Okay. Not terrible? Rational zeros they're something. So let's go back and see if you remember how to use synthetic division. And we're just going to do this with, they're going to give you possible zeros of plus or minus 1 and 2. And they just want you to check and see if these values are zeros. Now, how do you determine if something is a zero? Yeah, if it ends in a 0. Good. So if I'm looking at that first problem, it says 2x to the 4th minus 9x cubed plus 8x squared plus 9x minus 10. It's a 4th degree polynomial, which means it has how many parts in its sequence? 5, okay? How many total possible zeros could it have? 4. How many changes of direction could it have in the graph? 3. And what are our tails doing? They're up, okay? Perfect. So if they're telling you to check to see if 1 is a 0, negative 1 is a 0, 2 is a 0, negative 2 is a 0, here's where having an eraser is your friend. Do I need any placeholder? No. Do you remember what your first step was? Yeah, bring down the 2. And then what do you do on the outside? Multiply. What do you do on the inside? Add. Hey, look at that, it's a 0. So I know that 1 is a 0. Do you remember my trick, or if we were trying to remember if things were zeros or not? It's a 0 because I circled it. The circle looks like a 0. And if 1 is a 0, what's its term? X minus 1. Okay. So I know that 1 is a 0. All right, if 1 is a 0, for this case, they're trying to figure out how many of them are the zeros. Well, I know 1 is a 0. Now I got to check negative 1. which means I go back and I erase my work. Or I do it again. Just rewrite it. If you want to rewrite it, it's fine. If you want to erase it, fine. Just one of those things that just going through. It's really a practice in synthetic division here with some pretty quick, easy numbers for a lot of this. Because as we get further along into the last bit of 6.6 and 6.7, you're going to get really, really good at synthetic. By about now, could you, well, let's see, we get negative 19. Hey, look, it's another 0. And we go again. Hey, look, I found another one. It's crazy. By about there, can you kind of go ahead and say, no? And that's what we're doing today. We're checking to see if those 4 work. You'll be able to tell pretty quick as you get better at it, as you start using some number sense, you'll start to realize that as you get through, I don't know, 2 steps of it, you can probably start to think ahead and recognize that something's not going to work. And trust your gut. If you think it's not going to work, you try. Yes, ma'am. No, not at all. I mean, it wouldn't be a bad idea if you get to this part just to double check yourself, maybe make sure you didn't make a silly mistake. But it's totally possible that it's not going to work, and that's fine, and that's good because then you're what is it, foreshadowing, predicting. That's why it's taught. So. Oh, I gotta show you guys something today. Take a second. I'm not showing the commercials today. All right, you guys take a second, check those. Which ones are zeros? We can't have all 4 of them being zeros. Why? Why can't I have all 4 of those being zeros? Predictive, right? Why is this not charging? That's weird. There you go. don't want to go farther because then it gets a little bit out there. I want you to save that for the other later. Okay. So I'm gonna give you a few of these to work through. I put two problems on there. That's asking you to find all the real zeros. Which means I'm going to see if you can figure out what to do with those two. Okay? Give me a second. I'll pull this up. You can take a picture of it. Otherwise, I'll have the PDF here in a second on the confuser net. There you go. You can at least put all of those on there now.